Okay, recording. All right. Welcome to the July edition of the Utah Data Engineering Meetup. So this month we have Craig Wright and Kristen Bagnall from Fivetran. They're going to talk about the modern data stack. So this is pretty exciting. I always give the story of back in 2015, one of the founders of Fivetran had emailed me. I was at a Redshift data warehouse at the time, and he's like, you should try out this product that we built. You can move data in seamlessly into your Redshift instance, and we'll only charge you $100 for it. I was like, that seems too expensive, and I'll just write it myself. Years later, I think it was a colossally dumb decision. So Fivetran's always, I think, held a special place for me, partly because of that memory. So this is pretty cool. The Fivetran's done a lot of impressive stuff. I think modernizing and data pipelines and getting rid of a lot of undifferentiated heavy lifting. So this is going to be a pretty cool talk. We want to go through who's hiring and who's looking real quick. People used to be hiring. I don't know anymore if anyone's hiring, but if anyone is, you want to give a quick shout out for your company and any other relevant details?
Recursion is hiring data scientists. We have a data scientist role and a senior data scientist role open.
Awesome.
I think I already posted it. No, I didn't post it to UDEM. I'll do that.
Okay, cool. And if it's in the chat, you can post it here too. Zoom land. So, cool, thank you. So that's Recursion. They're awesome. A lot of smart people there. So you get to work with Isla. She's awesome. She's really smart too. So cool. Anyone else hiring? Okay, that's great. Well, if you are and you forgot that you're hiring, feel free to post either in the UDEM Slack or in the Zoom chat. So is anyone looking for work? Going once, going twice, nobody? Okay, well, if you are, we do have a looking for work channel in our Slack group. And as always, if you are looking and don't want to say it publicly, I guess you could ping the person who said that she's hiring and you can take it from there. So this is a good track record. We usually have a negative unemployment rate, and here we are again. So good job, everybody. Upcoming events this Friday, there's kind of a spin-off group, the Data Nerd Herd. It's more a discussion-based group. And so we tend to meet on randomly on Fridays around lunchtime and have a discussion about topics. So this Friday, Freddie Drennan out of Denver is going to talk about some cool stuff he's been doing with figuring out Reddit threads and doing sentiment analysis on those. So that'll be really cool to check out. We're probably gonna have more events for the Data Nerd Herd, so just stay tuned on that. LCC Python, that's been going on for a while. That's every first Wednesday of the month. I'm not sure what we're talking about, but we'll find something to talk about. So we always do. The next Utah Data Engineering Meetup is August 19th. This is the third Wednesday of every month. So we have Apache Kylan. That'll be the topic. And so that'll be pretty cool to check out. So they're gonna talk about simplifying machine learning on big data. So it's always a fascinating thing to see how that's progressing. So if you want to give a talk, just hit up an organizer like myself or Fernando or Devin or anybody else, and we'll get you sorted out there. So we do have a Slack group. Again, message an organizer, or you can email me here and I'll add you. So this is a virtual meetup. I think everyone's kind of figured it out now. Stay muted unless you want to talk. Q&A, Craig, are you fine just having people ask questions as we kind of go along, or do you want to wait till the end?
Yeah, I don't really mind. Occasionally I might say, like, I'm going to talk about that in a few slides or something, and then maybe bring the question back up then. But overall, I'm very open to interjections.
Cool. So interject away. I'll be fielding some of the questions in the chat as well.
Yeah,
So
Slack or Zoom does the thing where they kind of emphasize the person who's speaking to make it feel like a meeting as opposed to a group chat. So you might have to yell a couple times to get through the Zoom filter, but I'll try to leave some space.
cool. Awesome. Well, with that, I'll let you get set up there and we'll get started. So thanks.
Cool, thanks. Let me just arrange my monitor. Oh, okay, great. Yeah, for some reason we kind of don't use Zoom at Fivetran, so even though I've used it a lot in the past, I always forget how it actually works. Okay. Well, first of all, thanks for having me, Joe. I really appreciate it. Appreciate the chance to talk to all y'all. My name is Craig Wright. I am a partner engineer at Fivetran. My job is to essentially be a technical and product interface for all of our partners. That includes like partners like Ternary Data. It also includes partners like AWS, Google, Snowflake. So sort of both sides of the coin. With me is Kristen Bagnall. Kristen is she's an analytics, senior data analyst. She has been pioneering something I'm going to talk about later, which is our sort of our integration with DBT. And so she's on the call in case, once we get to the DBT section, if we want to, kind of drill into the nuts and bolts of DBT, she can definitely take those questions. My career history, I was a developer at Yahoo working on Yahoo Mail, like many, many years ago. Since then, after that, and I was a developer manager, and then I moved into partner engineering because I was really interested in that interface, that technical interface between companies that somehow generates value. So I worked at a startup. After that, I worked at Twitter doing ad tech, ads platform partner engineering. Then I worked for a company that was selling Kubernetes for about a year and a half. So Kubernetes management and application deployment automation. And now I've been working for Fivetran for the last year or so, talking about, Fivetran solution for data pipelines and data ingestion. I think the only real theme there is that I tend to have worked at companies where the the solution is pretty big and complex. So it's a lot of, diving into this really complex topic area and then going to the next one. Okay, so I wanted to say apologies in advance because the topic of this talk is kind of inextricably wound up with the product that Fivetran sells. So, I'm going to be doing a lot of talking about Fivetran, and a lot of what I'm going to be sharing is this, really core to Fivetran's identity. I'm going to be doing a brief product demo to kind of illustrate what I've been talking about. So, it's not my job to sell, well, it is my job to sell Fivetran. It's not my job to sell Fivetran at a meetup, but it's kind of core to the talk. I'm hoping that there are, more general lessons to be learned from what I'm talking about, but I don't know. You guys can tell me at the end if that's true. Well, who is Fivetran? I wasn't sure how I could smash cut between these two slides, but anyway. So Fivetran, we've been around for about 7 years. We have a bunch of customers. We sync a bunch of data. We have offices kind of all over the world, Oakland, Denver, Bangalore. Actually, we have an office outside of Moscow. We have an office in Dublin. We just opened an office in Australia. So we've been pretty successful doing what we're doing. Most recently, we just closed a Series C round of funding that was big enough to get us into a certain class of company. But in any case, enough about that. So what I'm going to talk about is the benefit of automated data ingestion and a little bit why now as opposed to any other point in history. Like why is this solution presenting itself today? I'm going to cover the problem. Oh, go ahead. No, okay. I'm going to cover the problem case, which is basically, I mean, this kind of goes back to the beginning of time, but it has expanded rapidly, which is the problem of centralizing all of your business data. This problem has kind of expanded in scope as we have turned to software as a service solutions for running most of our business applications. So we're getting away from the world where all of our business is in a few major or even many major on-premise applications, you know, in the form of a SAP database or an Oracle database. Now our data is kind of proliferated, and you know, at least speaking for the companies I've worked for in the last few years, we've had data spread over, you know, anywhere from a dozen to, you know, 20 plus different SaaS applications. And what we want to be able to do is merge that data together to be able to create insights that are relevant for our business. The problem with doing that is I mean, it's very difficult to scale across that many data sources, and homespun approaches to ETL tend to be very labor intensive and very brittle. It's, you know, having to keep up on the changes to an API over time is a huge effort and requires quarterly, if not monthly, reviews of an API changelog. I was on the vendor side of this when I worked at Twitter, and you know, it was a big effort to get everybody, you know, moving with the changes that we needed to make to the API, because, you know, at Twitter, I always said I wanted us to be the best third choice after Google and Facebook. So we were competing for attention to get people to update their APIs. And in this world, everybody who runs a data pipeline is competing with, you know, with however many data sources you're trying to merge together. You know, keeping on top of schema migrations is hard. Managing incremental loads to minimize cost is hard. Failure recovery is hard. And the challenge is whenever you have a new question at the end of this pipeline, it usually involves having to go back and re-engineer the whole thing. So, you know, if the CEO is like, oh, the last report you did was great, now I need this report to follow up on the information, with sort of the traditional pipeline model, you wind up having this chain of responsibility that has their own work queues and their own potential to not be available for that change. And that change has to percolate all the way up to the chain. So obviously the ideal scenario here is to have essentially a pool of data that you can draw on to just start generating insights, whether they, you know, that's available to your data analysts, data scientists, even just, you know, your kind of, I don't know what you'd call them, your plebeian users using an analytics tool. So what we kind of came to, and we came to this very organically. Fivetran was originally building an analytics, a business intelligence tool, kind of like a more simple version of Sisense, that was like this kind of spreadsheet tool. And to build that tool, they wound up building this data connector. And one of our early customers said, hey, I do not care about your BI tool, but if you can build me more of these connectors that get the data into Redshift, that's worth something. And it kind of spun out from there. That's where we started to realize, oh, this is actually a hard problem that people are really struggling to solve, and they don't want to spend the money to solve it themselves. So the big change here is that rather than asking people to deploy and manage their own pipeline building tools, Fivetran is a fully managed service, and you know, I would argue that the future is going to migrate to fully managed cloud hosted services that are automated, resilient, and, you know, cloud deployed. The presumption here being that your business is already sort of part of this migration to the cloud. And that's kind of an important part of the story. It's how the cloud, like the migration to the cloud, has changed things. So what we're sort of arguing for here is what we call the modern data stack. But we also find that to be very simple. And actually, I was introduced to a new term today from the DBT folks, which is composable. I'll talk about the composability later, but right now I'm going to focus on the simplicity. sort of our key argument is we're breaking the old ELT model or ETL model into extract, load, transform. The concept here being, rather than do aggregation in flight, just have a very predictable process that migrates your data in a reliable, consistent way, put that into the data warehouse and transform it in the data warehouse. So start to create your cleaner and cleaner tables all kind of post-load. So you constantly have that raw data. So you, again, to talk about composability, you want the extract and load part to just work. Creating these normalized, this kind of like foundation of normalized schemas, so that you can then do your transformation and modeling using the power of the data warehouse. I kind of already mentioned this, but the way this is separating out from what the traditional ETL model is in traditional ETL, because of the constraints of the time, which I'm going to get into, we got accustomed to doing aggregation in flight or doing a lot of transformations in flight, and before it actually landed in the data warehouse at the time. I'm going to talk about this, but basically that isn't really a constraint that is particularly meaningful anymore. Like how much disk storage we're using isn't particularly meaningful, and the compute cycles that it takes to get this done in the warehouse isn't competing with the compute cycles of, trying to get these reports generated for analytics anymore. And to kind of like really drill this home, I was looking up on Wikipedia sort of when ETL as a concept came up. And according to Wikipedia, I mean, we had this term as long ago as 1970s. And, you kind of feel that in the industry, but I was actually surprised that term was coined so long ago. And when you think about the constraints that we had in that time period, like, the oldest information I could pull was 80s, but in the 80s, a gigabyte of data was, we're looking at somewhere around $100,000 per gigabyte. That's a pretty hard constraint, right? Like if you're talking about what you're actually going to store on disk as a result of your what your applications are generating, like the concept of doubling your cost of storage to do reporting when it's $100,000, per gig is a pretty significant expenditure. But the trend has been, lower and lower and lower and lower. In this chart,
are you?
Yeah, shoot.
You're not emptying the dishwasher, are you?
You're working.
I'm gonna do it.
You're working. I think
I know.
I'm good.
Okay.
I don't think that's a question for me. I am not emptying the dishwasher. In any case, long story short, so, precipitous drop in things like the cost of storage. Even in the last 6 years, we've gone from 12 cents down to around 2 cents per gigabyte. So this is approaching zero. And, I'm not saying this to say that there isn't a cost of storage in the modern world. There is. But just that when we think about the time period of which I feel like tech is very today focused and tomorrow focused. But this is an instance where when we look at the practices that we've been engaged in, they come from a history. And it's important just to recognize that history when you're thinking about how things are shifting and why you might, how things might be shifting in the future. The other part of this, and this is kind of an integral part of the modern data stack, is that modern cloud warehouses that are, like BigQuery, Redshift, Snowflake, they're fast. I stole this from a sales slide, but the important part here is, historically, we're talking about a data warehouse would be a single node database. And in that sort of processing and storage cost model, it makes sense to spend some time aggregating data, reducing the size, storing less of it, so that you're paying less to get it out. With a modern cloud data warehouse, we've got to the point where storage and compute are separated. They're able to be billed discretely and managed discretely, and also scaled independently of one another. And that's created some great efficiencies that we can rely on to, essentially model that data after it's already been loaded into the data warehouse. So how fast are they? Let me tell you. Oh, killer. We haven't quite finished our 2020 cloud data warehouse. So every couple of years, Fivetran benchmarks all the cloud data warehouses. The last one we did was 2018. The 2021 is like so close. We're kind of going back and forth. Amazon wanted us to redo it because of their new RS4 instances, and we didn't do it the way they wanted. So we've been going back and forth with them, but that should be out anytime, really. So it should be the same link too. So definitely check that out if you're interested in sort of, you know, a showdown between all these big players. Okay, so how does this actually work, or what does this look like when it's operating efficiently? The key component of this on the sort of inside the process is automatic schema migrations. And the kind of core concept here is no matter what the connector is, what we want is a super consistent process that then loads it into the data warehouse in terms of how it transforms that data. We essentially want that layer of transformation to be as predictable as possible and to generate essentially like the same results for similar types of data, no matter what the source was. So that to me is like very key to this whole sort of concept. And even if you're like, I'll never buy Fivetran, but I want to implement this myself, like to me, this is kind of the key insight is like separate those two pieces of functionality, like how you talk to the warehouse and how you transform the data to do that. If you can modularize that from the actual connector process, you're going to buy yourself a lot of sanity, basically, on the maintenance. But long story short, if you already have normalized schema, great. The process there is, the hard part there is to actually integrate in a way where you're minimizing usage on the source database. Fivetran does that using replication logs. So if we're talking to Postgres, we're using their replication slots. We've just started implementing, we were using LogMiner for Oracle, now we're using Flashback. MySQL will use bin logs, right? The goal here is to just essentially be able to read that log and do the change data capture without having to do table scans for every single update. And that's hard, right? Like Oracle, you can have this multi-gigabyte commit transaction that actually never gets committed. And so, you know, kind of building that logic into something that's reading these logs is a little bit challenging. Ultimately worth it, but challenging. And then so for those normalized schemas, what we're trying to do is just, you know, A, minimize the cost of change data capture, but then B, just make a minimal amount of changes necessary to get it landed in the data warehouse in a way that the data warehouse understands, mostly just changing types. And then the kind of like the major value of a platform like Fivetran is what we do with denormalized data. So when we're interacting with a software as a service application like you know, Marketo or Zendesk or GitHub or what have you, we're essentially part of our development process, the very early part, is designing these entity relationship diagrams that act as a blueprint for how we're going to then implement that connector. And often we'll try to work with the source vendor if we can to match this as much with their internal understanding or their internal representation of the data as possible. But the real value of this is then at the other end of the development cycle, we're able to publish these ERDs, and we now have, you know, 100+ of these, and that creates this really stable foundation of what what a schema looks like for any particular application. I'm kind of going to get back to the importance of that later, but that's kind of like that. There is a huge value to having that like really consistent, predictable schema. And you know, if you're a consultant and you're working across multiple companies, you know, and they're all syncing like Marketo, it's, you know, you'll know that anybody you're working with, you know, they're all going to have that same schema if they're pulling it through Fivetran. Or if you're in the same company working across departments or what have you. There's another benefit to that I'm going to talk about later that I don't think has been realized yet, or it's just being realized. But anyway, I'll get to that. our philosophy, and I would argue this is kind of very in line with the, store all the data philosophy, is we try not to ever delete anything. So, if we remove a column, we don't remove it. We just start filling that data with nulls, create an audit log entry, that column was deleted. If you remove a table, just leave it. Audit log entry, table is removed. Type migration is the only thing that's a little iffy, but if we had a column that was all Booleans, and then we find a string in the middle of that column, we're going to upconvert that type to be something that can contain all of the values that we found in the column. So we use the source column types basically as hints, and really focus on what data we found to do the migration. And again, like, this is kind of part of that, how do you actually create a robust flow? And it has a lot to do with, being flexible to the data you're actually getting. Flexible, but predictable. So it should be, you should know what data type you're going to get out the other end. Inserts work the way inserts would. Deletes, again, part of this process is creating a little bit of metadata that tells you what happened with a sync or what's happening with the data. In this case, we add a Fivetran deleted column. So if something gets deleted, we just mark that true. And if a customer wants to, they can actually run a transformation to delete all that data. Like, they have limited storage requirements, or they have GDPR requirements or something like that, where they can't store the data. But for the most part, this serves the need of not breaking queries. So ultimately, what we're trying to do is make sure that these schemas can migrate without the analyst or the data scientist having to go completely redo their models every single time there's a minor schema change. The data may drift or may be inaccurate. You may have to go back and update it to be actually correct, but we don't want it to be just completely broken, just completely fall over. Updates are a special point. We actually do delete data on update, in the sense that we update the row with the new data, and the old data kind of disappears into the ether. We're actually going to release a feature that takes care of that later. That will capture those changes. That's coming later this year. But again, that's just more about the robustness of the solution. And then once you actually kind of get that engine going, the real value add, like if you were to build a competitor to Fivetran, the value add there is then creating a huge list of supported connectors. And the thing that's important about this, like when I first started working for Fivetran, or when I was interviewing, my kind of sense of it was like, oh, okay, they do all this like terribly boring work, so that the customers don't then have to do that, reducing their total cost of ownership, blah blah blah. But at the end of the day, like, you're building connectors. I mean, how exciting is that? And what I've kind of learned over the last year is that there's this huge centralization. Once you start actually scaling this, then it gets actually super interesting. And like adding whatever new API or updating a connector because an API changed. Yeah, that's kind of the hard grunt work that you do when you're doing this. But on the more interesting side is like when BigQuery adds a new optimization in terms of like getting data loaded even faster, or streaming data directly into BigQuery, or whoever. We can make that change, get it to be super efficient in a wide variety of cases, and then deploy that to all of our customers simultaneously. So there becomes this like really this value in scale, where now it's like, oh, we are basically the experts of loading data into X, Snowflake, and all of our customers get that benefit. Kind of a sidebar, really. I don't know why I talked about that, but I kind of find that interesting. Actually, another interesting case was when Snowflake introduced the cloud services layer cost model. That forced us to do a big change in terms of how we approach the problem. So again, you learn that you have to balance how to balance those costs and how to optimize. Just to show briefly what this looks like. Oh, and a kind of hot tip, but what this looks like in practice. First, the hot tip: if you do set up a Fivetran trial and you don't have a data warehouse, or you don't want to pay for a data warehouse for a couple weeks, we have this feature called Fivetran Managed Warehouse. If you click in here, basically what we'll do is we'll set up a BigQuery for you, and you can use that for the duration of the trial and not have to pay for it. And then if you wind up paying for Fivetran, we'll give you the BigQuery account, then you have to start paying for it. But this is kind of a good way to just try out the product. I basically tell all my partners that. Anyway, moving along. So this is an account I've set up with a Snowflake warehouse. And just briefly going to show what it looks like to set up Salesforce. So, and the point here is sort of like this part should be as minimal as possible, and the effort should be spent on the analyst side. And I mean, it's going to be pretty apparent. Schema name is permanent. That'll show up in Snowflake, and you can't change it. And then the authorization process is literally just you pop through an OAuth flow. I already did it once today, so it didn't pop up, but who am I? And then do I authorize Fivetran to take my data? The answer is yes. We make sure the data is accessible. I'm gonna take a quick drink of water. And if you're connecting to something like a database, there's actually quite a few more connection tests. Something with a little bit more sophistication in terms of how we have to connect to it. With a database, you generally have to punch through a firewall somehow. And so that, might involve starting up a VPN tunnel and connecting to the tunnel and blah, blah, blah. But for something simple, it's API driven, it's pretty basic. And once this loads, the point is like, that's basically it. I'm getting the too many people on the Zoom lag. Yeah, so that's basically it. At this point, with any kind of database connector, we kind of have this process where we ask you to review the schema. This is essentially the only place where the user can influence the data in flight. I kind of call this like our only in-flight transformation capability. And all you can really do is say, I don't want to import this table. You can dive into a table and say, I don't want to import these columns, or you can hash a column. I can explain hashing later if folks don't know what that is, but that's basically it. And I used to kind of I don't know, talk this down a little bit, like, yeah, this is all you can do. But we were helping a competitor who was offloading customers. They were deplatforming customers for whatever reason. And so we were talking to them about that and showing them this interface. And they were like, yeah, that actually takes care of about 60% of our transformation use cases. And I was like, whoa, that's awesome. Okay, I'm going to talk about this more. Anyway, that's basically it. So at that point, I would start a sync and data would start flowing. I don't know if we have anything. This is the Salesforce on the other side. I don't think we've turned on Salesforce. This is our production Salesforce, so we use up our API rate limits if everybody who's demoing turns it on. But right before this, I did set up a GitHub connector, and it looks like that finished. It took that's shorter than last time. It took 6 minutes to import the information from one GitHub repository, and that showed up here. So this is the Sock Shop is this demo we used to use at my previous company. And actually, I forgot this query, but kind of just to illustrate what I meant about these ERDs, like if I wanted to, so this is the ERD for GitHub. If I wanted to just like select, like look at a commit log, let's see, SHA, committer email message. So it should be pretty easy to just select. Let me see if there's a date, committer date. From GitHub, CRW. Right? Maybe. We'll see. Oh, awesome. Yeah. So, I mean, this is obviously like a very trivial example, but my point is like, having that kind of like, oh, this is the schema, it's published, I can just go get the information and, whip out a query on it, is pretty powerful. This is going to come up later, so I'm going to, I've been talking about this concept of ELT, and so just briefly, in this model, in this worldview, transformations happen in the data warehouse. And the way that shows up in our product is that we have this really simplistic transformation scheduling feature. And all this really does is it lets you run one or more SQL queries in whatever the data warehouse supports, whatever language data warehouse supports. Either when data is loaded into a table or on a time schedule. Very, very straightforward, very simple functionality. The reason I'm showing this is that I'm about to talk about it. But, yeah, actually, in fact, literally the next thing is T stands for transformations. And, one of the places where I felt like this, as somebody who's pitching Fivetran all the time is extract, load, transform. But like, how do we actually talk about transform? And so lately, I guess I could have talked over this one. Like, how does this actually happen in this model? So before, your tool was doing the transformations for you in flight. So now that scheduling has to go somewhere, that modeling has to go somewhere. The easy mode solution, the very kind of easy to understand, is just plop it in a Fivetran's interface, let it run it for you on some trigger. And, don't do anything very complicated, or if you are doing something complicated, do it somewhere else. Do it in another proprietary tool, or do it in the data warehouse's tooling, or what have you. I'd like to talk about a different solution to T, which is around this tool called DBT. And they're phrasing this term called analytics engineering around it. The tie-in here is this is kind of, if the modern data stack is the cloud data warehouse and the data itself, DBT is kind of part of that answer for how do we think about transformations. So DBT, it's an open source command line based tool. Fishtown Analytics sells a graphical user interface to DBT, but that notwithstanding, the open source project is basically command line driven. That allows you to run repeatable, testable, and source-controlled SQL commands. And they have this kind of like real strong ideology, not unlike Fivetran actually, but their ideology is that they think data analysts are going to start working more like software engineers, which I think can be a little bit of a triggering claim, but I think it's right, and I'll talk about why I think it's right in a minute. And they're calling this sort of applying traditional software development methodology to analytics engineering, to the data analyst domain of specialty analytics engineering. I'm kind of excited about this for a couple of reasons. I guess I'll get into it. But the thing I love about this drawing, my next few slides I kind of stole shamelessly from DBT, but what I love about this is that DBT sees itself as this whole part of the stack, and Fivetran is sort of just this little sad gray box hanging off the side here called data loaders. The thing I love about that is, I give the Fivetran presentation all the time, and there's just like this sense of self-importance, like modern data stack, we're enabling this and that. And as soon as you move to a different part of the stack, it's like, somebody does this. But we do all the cool stuff in the middle here, and I don't disagree with them. Fivetran is basically like this part, and DBT is doing all of the kind of the rest. We recently started working with Databricks, and Databricks has this really cool, I just kind of keep thinking about it, this metaphor for the quality of data in a table. And so like the raw data here would be the bronze table. And then as you do transformations on that data, you clean it up, you get to your silver tables, and then you run whatever process, like, usually a more advanced machine learning process, and you get to your gold tables, bronze, silver, gold. And in that model, I think of DBT fitting really well in this. you have your bronze tables delivered. It's high quality, but it's still basically raw data. Not quite ready for actually presenting in an analytics tool or for modeling. What bridges that gap? And arguably DBT does a great job at that. There are kind of these 5 key components that I think make DBT really great. The first is that it's completely defined in SQL. Granted, it's SQL that is template. It's in a templating language. If anybody's familiar with Python, which I imagine most of you are, the templating language is Jinja. So it's not even like some weird obscure templating language. It's basically the standard for Python apps. And DBT, the tool, is written in Python, but the language that you use as a user of DBT is basically just SQL, which is awesome. By essentially breaking your SQL out into files, you can now version control it. Once it's version controlled, you can start doing integration testing. They have tools for doing automatic documentation generation. And as you actually build this into a CI/CD model, which is now possible as a result of getting your SQL into just basic files that are managed by this tool, now we have CI/CD, we have logging, we have alerting. We have a lot of benefits that start being generated out of this model. And this is kind of the magic of the templated SQL model. As you write your queries, you include references to other parts of the model. And what that allows DBT to do is create these renderings of what the data lineage looks like. And the top part that you're seeing here is, this is a really cool animation that Claire Carroll from DBT did. I feel bad because I'm stealing her thunder. I think you guys will probably get her to talk at some point. But she said I can use it, so it's fine.
Well, that's fine. Yeah, I've been talking with Claire on and off. She's been slammed, but I think we'll be having her give a talk at some point soon. So
yeah, I'm trying to walk this edge where I talk enough about DBT to get my point across, but not so much that then she has nothing to talk about. I think she'll have plenty to talk about.
yeah,
But yeah, the point here is like once you kind of just make this small break between, oh, now I can separate my SQL into different files, and then connect those with references, it enables this really awesome directed acyclical graph generation that DBT can do and build those models in the right sequence, and then document what those models look like, document what the data pipeline looks like as a result of that, running that process. I kind of already hyped this up, but once you get the stuff into source control, then you can start applying all different kinds of automation. This is an example from their deck that shows that they're running like a CI process every time someone commits something to the package repo or the project repo for this DBT project. But this can be expanded like hugely. Yeah, I'll get to it. Sorry. In terms of the power of documentation generation, this is actually our NetSuite package, which I'll talk about in a second. But this is kind of like we just run dbt docgen. Is that the command? Dbt doc, yeah, yes, dbt docgen, and it cranks this out, cranks out the lineage graph, and also this is a view of the DBT graphical user interface. But you can see here that it's also generating documentation about the column level data. And this is super cool because now you have essentially like this data catalog that is being generated automatically. I don't know if they have it plugged into real data cataloging systems yet, but that is kind of, an obvious next step. So, again, I said in the beginning, like I kind of have come from a bunch of different specialties. And the reason why I find this to be particularly exciting is, I've kind of seen this happen to an industry before. And at my previous job, which was very focused on DevOps, and the migration to the concept of infrastructure as code is sort of revolutionizing that discipline. And it's based on a lot of the same principles. Like once you can abstract your configuration, then it creates this whole world of ability to do, sanity checking, having code reviews before you deploy anything, having automated deployment infrastructures. getting even to the point where not only is your infrastructure deployed, and each of these is kind of like a level of, a next level of abstraction of what is deployable. But not only can you deploy your infrastructure with something like Terraform and Ansible, and then start to deploy your applications via configuration with something like Kubernetes, but you can even get to the point where you're deploying the monitoring and the alerting automatically in an automated fashion with Prometheus and Grafana. So if the entire western half of the United States falls into the ocean along with your data centers, somebody should be able to just run the scripts that execute all this configuration in the code. First, be able to read the scripts and understand what it was doing, then run it and rebuild your entire system, basically from scratch, doing very minimal amounts of work. Bringing this kind of reproducibility and consistency and discipline to analytics just seems obvious to me. But this is kind of the world that I came from. And again, I think getting the definition of these things into source control is like the key innovation. Once it's in source control, it just unlocks the possibilities. I kind of talked about that, but I just kind of super emphasize, like, this is so important. And one of the things it unlocks is the ability to then depend on other packages. So DBT has this ability for you to you can create a DBT project and then say, oh, I want to include like these template helper functions from over here, or I want to include this package that builds a model from over there. They have these all listed out on a website called DBT Hub. For the most part, I think this is all open source. And this is where it comes back to kind of when I was talking about composability, what's the composability model here? Well, now Fivetran can build packages on top of DBT that take care of a lot of the most standard modeling that our customers might be interested in. The first example that we always go to, we've done this a couple times. We created packages for Tableau, and then we did some blocks for Looker. And I think now that we've done them in DBT, we're done. I think we're just going to use DBT and tell people like, okay, push that into Tableau. But NetSuite is always the first one we do. And the reason is that Fivetran moves the data and it moves the schema, but it doesn't move the views. So when you get to the other end of that, you have all the data you had in NetSuite, but you're like, oh, that's not what it looked like over there. That's kind of like this huge missing piece. So we always wind up rebuilding that on behalf of our customers, because a lot of those views are fairly standard. NetSuite's very customizable, but frequently like what you're trying to get out of it is pretty typical. And so being able to just say, hey, you're using Fivetran, you have this foundation of data. Now you're using DBT. Well, okay, it's open source. Here's some open source packages that help you manipulate that data. We know what that data looks like because it always looks the same because it came from Fivetran and in this standardized way. We can now scale kind of horizontally across this community to make their lives easier in a whole new way. So anyway, find it super exciting. We've done the 6 packages on the left. Salesforce, NetSuite, Marketo, MailChimp, GitHub, Asana. We're working on HubSpot, Zendesk, and Stripe. Those should come out very soon. Kirsten and her team have been cranking out about a package a week, maybe a package every week and a half. And we're going to do as many of these as we possibly can. Concept being like, the more of these that exist, the more useful they are in aggregate. And this kind of, I guess I kind of already talked about this, but this gets to the scaling advantage that I think we're going to find eventually, that you have this foundation or of all these very standardized schemas. And on top of those schemas, we can start to build tooling that works for anybody at any company because the schemas all look the same. I'm kind of repeating myself, but I think this is like, as I think about what possibilities exist to go interact with communities of users, this to me seems the most potent, where we're actually able to create this reusable tooling, ideally as open source packages, although Fivetran's not we're very new to open source, but that's kind of the direction I want to go with this. And then eventually what I'm hoping is that, we're starting with DBT, and maybe the future is that we'll start to actually build tooling out across a whole new domains of interest. So, this is kind of, I feel like we're just getting started on this, but I see a lot of potential value to continuing to grow how we're able to build tooling on top of our data. The other thing that we're doing with DBT is we're going to do an integration. So you'll actually be able to schedule DBT jobs out of Fivetran. This is very not finished yet. It should be releasing kind of in the beginning of Q3. Q3 for us starts in August. And the very first version will just allow you to schedule based on a time, on some kind of time chooser. Oh, and that's it. I've reached the end, probably thankfully for most of you folks. So yeah, please hit me up with any questions after this. Obviously, you can ask me questions now. I didn't really give anybody space to ask them during the presentation, but please ask questions now. You can ask me in email. I'm also at CRW at Twitter. Kristen doesn't do Twitter, bless her. And speaking of hiring, I'm also hiring. I'm hiring a developer advocate, which could actually probably be called data practitioner advocate, because I'm looking for somebody from the data science or data analyst space to go actually, do the work that I was just talking about, like to go find where we can actually extend the platform into different communities. I will end it there. Thanks, everybody. I appreciate it. Appreciate everybody staying the whole time.
Awesome, thank you. There's actually a question here from Fitz. He asks, are there sources Fivetran supports that don't have the CDC logs you described, and how do you handle those?
I'm trying to think of obviously any API does not. With APIs, you got to figure out how you can set cursors that matter, so you're not, pulling data. And I don't know if you remember when I was showing the Salesforce screen. Oops, whatever. It's all the same. You'll see a bunch of tables that are unchecked and uncheckable. And actually, these are tables that we can't sync because they don't have any value that creates a unique enough key for us to be able to do an incremental sync. For the most part, these aren't tables that are particularly important, but it is something that is a hindrance or can be difficult. So, I'm not claiming that this is perfectly 100%. You can capture every bit of data and do incremental logging. Some data sources, very few relatively speaking, but some data sources do require either just blind insertion or continuously re-importing the entire batch of data every time. We have one connector I was shocked to learn a couple weeks ago that's what it does. We recently changed our pricing model so that we charge based on the number of unique row IDs, and just the combination of factors meant that this connector was like resyncing every day, generating a ton of extra cost. So we're actually replacing that implementation with a new one, but before in our old cost model that actually made sense to do. It doesn't make sense anymore for our customers, but yeah. Did I answer the question?
It says, so. Yep. So, cool. What other questions you guys got?
Is there any tooling to help folks build the ERDs, or is that something you do outside of Fivetran? And then
I don't know if you noticed, but our ERDs are actually created manually in Google Sheets, which was also shocking to me. So the answer right now is no. We're not automatically generating the ERDs. And part of that is because we're designing them before we actually have built them. So the generation part of it has never been super important in the sense that we've already generated it manually as like I said, as kind of a roadmap for how we're going to implement that connector. That said, I'm guessing there's tooling that exists to do that, but yeah, we're not producing that right now. That would be pretty helpful for like when you're importing your own databases, your own application databases.
I mean, do you
And
publish those ERDs though?
yeah, we publish all of them. So
Okay.
that's kind of like the underpinning of my argument, which is like when you have this huge mass of published schemas that are consistent across anybody who implements Fivetran, creates this opportunity to create value on top of that, right? Because it's standardized. Like the more you can get these processes standardized, the more composable they are. And granted, Fivetran's piece of that is proprietary today, right? Like it's possible. Like imagine a future where we've created so much tooling that's based on the Fivetran schemas that some company intentionally replicates those schemas. That would be the day where I basically quit. I'm done, because we've proven the value that having standardized sets of data provides. But
yeah, this ERDs would be nice. I mean, I was actually just helping somebody today try and figure out a data import issue, and they're like, what tables do I use? Like,
one of our partners actually has to build their models completely off of the ERDs because they don't have access to the data warehouse. It's this weird setup. But and every once in a while they'll like Slack us like, did you guys change something? Like something's missing, and we have to figure it out. Either we updated a connector and didn't change the docs or something. But they're integrated with I think like 20 or 30 connectors, and they've built models for all of those, and they only Slack us like once every 3 months or something. So it works. I mean, it definitely works.
I mean, do you see companies that are, I think, still in the ETL mindset or mode? Do you see them warming up to the idea of ELT?
Yeah, absolutely. I think, well, so it's hard for me to say. I kind of have selection bias because I'm talking to a lot of partners who are already sort of have one foot in the cloud. Like they're probably already working with a cloud data warehouse when they come to talk to us. And once you've made that step, then you're already sort of ready to talk about, whoa, what does this hosted pipeline thing look like? Or, oh, what is the, I'm starting to understand the costs of the real cost of a cloud data warehouse, and whether or not the Fivetran solution actually makes sense in that cost model. And for some partners who are even in the cloud space, one thing that Fivetran doesn't have right now is the ability to land in a data lake or in a file format somewhere. And I was talking to one partner who was saying like, yeah, from a cost perspective, it doesn't really make sense for us to load all the data in a data warehouse for X, Y, and Z implementation reasons. And, we want that data to be in just sitting in S3 because it's way cheaper than going into Redshift. And I was like, yeah, fair, And again, that's why I didn't want the whole thing about the hard disk cost. Like everybody has their own constraints today. The only point of that was just, the assumptions that a lot of this stuff was built on are ripe for being questioned. But the reality is that when we're working and doing our day-to-day job, we actually have real constraints that, cost real money and, may or may not indicate a certain solution. Did I answer the original question? I feel like I kind of just rambled there. I apologize.
No, you did.
Yeah, okay, good.
Yeah, cool. Other questions, comments?
I didn't see an integration for Qualtrics. Is that something that's on your roadmap, or did I miss it?
Ooh, good question. I have never heard us talk about that, but it probably, well, the process is, usually sales folks will be out talking to customers and they'll start hearing requests for something. And, like, for example, right now we're really focused on SAP and Oracle and like more enterprise level stuff. And we start to kind of check like how many customers have been asking for something. Qualtrics, I haven't heard yet, but that's just my own bias. Like I'm sure somebody's brought that up already. So I could either check I could just check the Fivetran directory.
I think that we actually are working on that right now. Qualtrics is the survey tool, right?
Yeah, that's right.
Yeah. It's being released for private preview in, I believe, like 2 weeks.
Wow. There you go.
Yeah.
Nice.
We had a discussion with like the data team about the ERDs for how SurveyMonkey and Qualtrics should look. So in the works right now.
Nice. There's probably more things I don't know that are going on than I do, but that's great.
What would be your philosophy on, I guess in the real world, in my experience, the delineation between ingestion and transformation can be kind of gray. So I think you mentioned hashing. Okay, well, we'll consider that core part of the platform. But I think in the real world, there's all kinds of things, basic things like stripping white space, encryption, compression,
Yeah.
to more complex things like I have 3 different clickstream systems and I want a single view of it. What would you say is Fivetran's philosophy on where that delineation begins and ends?
I mean, part of it's pragmatic and part of it's ideological, but the philosophy is very much like there is a certain amount of transformation that Fivetran does, right, as part of its process. The way that you're talking about, like, kind of doing a little bit of string cleanup or, really we don't do that much, but, like you said, it can be fuzzy. And Fivetran does do a little bit of it, including things like deduplication. But in general, we're super ideologically focused on landing pretty much everything in the data warehouse and then doing any other kind of cleanup like in that place. And part of that is just based on this idea that the data warehouse should be able to do those computations more cost efficiently, as long as you're not worried about the cost of data storage. So like we're basically believe the warehouse is the place that is the most efficient for doing most of these types of operations. And so we sort of intentionally offload as much of that as possible. We also think that the more raw data has this latent value, and so the less you kind of do to it before it lands, the more likely you'll be able to answer questions in the future about that data. But again, I think it gets into these very pragmatic, like, does that actually make sense for the specific use case? An example of that is SAP. So one of the Fivetran ideological positions is, we do not ingest views. We don't do views, and a lot of times there's practical reasons for that. But in the case of SAP, a lot of the times the only thing that matters is the view. Like nobody actually cares about the underlying database. It's like how there's certain types of materialized views there that like that's all they want, right? And so that's where real world meets like our whole philosophy, and we're probably going to adapt in the future. Now I doubt that we'll ever do I could talk forever. I'll just leave it there. Did that answer the question, or do you feel like?
I think that's pretty good. Yeah. Thank you.
Yeah, I don't think we'll ever get to the point where we allow the user to inject transformation logic. I just think that'll be a core part of us forever, but never say never.
Right. I guess I was more curious about your roadmap, because I think there's a lot of work that I think ETL does that's non-value add, that's in that gray area. Something like a currency conversion. That's not specific to my company.
Yeah.
That's not specific to a data set, but it is in that gray area where it's not pure ingestion. And I guess kind of knowing what the roadmap is would kind of, well, I don't know how helpful it would be, but you kind of see, I really like the philosophy. Let's not do this stuff that's not value add for my company. So I really love that, and I'm kind of curious how far you would take it, because at some point it does conflict with the pure ingestion philosophy.
I think that gets into what kind of my vision is of how we can build tooling on top of the data that comes in. So I agree with you, and actually what we're doing with the DBT packages illustrates that perfectly, where, yeah, we land the data and it's in great shape or whatever, but that's not actually what the user needs. The user needs these materialized views, or they need these models. And we're just barely touching the surface of what's possible there. And especially when you look at enrichment, right? Like we don't talk about enrichment at all. And that's not really, it's possible with DBT, but it's not something that, we just don't talk about it. And that's something that's in this space of possibility that I think, we could get into tooling to help enable, but right now we don't. So yeah, you're absolutely right on that part. of where the system is strong and where it's kind of leaves some unanswered questions. I ultimately want to answer those questions, but I agree with you completely on that.
Thank you.
Yeah, no problem.
I have a question. Like, how do you suggest people structure their data warehouses um, uh, for, I guess, to create separations of concern? So you're landing your data in one zone and you're doing your analytics in another. Like, how do you recommend people set that up?
The easiest model for me is Snowflake because of their whole, like, the way they created their compute warehouses, and it's kind of different for every warehouse. Snowflake makes it easy for us because, and actually Redshift to some degree with its queues, but it makes it very easy to separate, like, oh, here's the ingestion warehouse versus here's the, the analytics warehouse, and sizing those appropriately. I mean, ultimately it comes down to cost, right? With regards to ingestion, we're always trying to reduce the cost as much as possible, regardless of what the warehouse is. So we're not like, unfortunately, when we talk to these partners, it's like, it's really hard to see the value of Fivetran from a credit consumption perspective because we're trying to minimize that as much as possible. We're trying to make this downstream argument, like, once they have the data, they can do whatever they want with it. But from the very first level, first order impact, it's very low. So we have a lot of strategies. There's a couple of ways to talk about this, right? It's like, how do you partition the data once it comes in to make it more accessible? How do you have even cross-region availability, things like that. We don't get too into that. Mostly what we're trying to do is just minimize the cost and make it possible for customers to have the cheapest possible ingestion point, whether that's an extra small size Snowflake or, like, you can create actually they do it automatically now. Redshift will actually automatically create a queue that is efficient for doing ingest. But that's kind of the extent of it. And then we'll do some smart data loading in terms of partitioning to make it easier to access when you're writing your queries. Beyond that, though, it's sort of on the implementer to do the right thing. And that is honestly where we're leaning on partners like you guys to sort of flesh out the ecosystem in terms of making those suggestions based on the specific use case of the customer.
Are there any anti-patterns you see, like, repeated over and over? Both related to that question, I guess, in general.
That's a good question. I'm not close enough to it. I don't know if Kristen, we'd probably want like a sales engineer or someone who's like constantly like executing customer implementations. I don't know if Kristen, you're a little bit more in the weeds on that side of things. Do you have any sense of that, or are you pretty much just?
Yeah. I'm not super, yeah, nothing comes to mind. Yeah, maybe a sales engineer would know better.
Yeah, I think, well, I mean, like, I assume you mean like smart anti-patterns, like, as opposed to, like, a lot of times we'll get somebody who's like, oh, I need to load all my, I want a continuous data stream from MySQL to Postgres or something. And we're like, or I want to load all my Salesforce into, some traditional database system. We'll do that. We don't like to. But like, once you get into like the actual, like, oh, I have this really sophisticated, BigQuery set up with, terabytes of data, that gets out of my sort of sphere. But I highly recommend, maybe I can do a follow-up answer on the meetup group from one of our sales engineers. They'll have seen it a lot more than I have.
Cool. Thanks.
No offense if
questions?
anybody's loading MySQL to Postgres.
Oh, I do it all the time. It's
Well, yeah, I mean, there's use cases, just, yeah.
I stream Kafka into a mainframe or something. Yeah.
Yeah. Hey, sometimes you have to.
What other questions you guys got? None? Okay.
Well,
Cool.
I'll throw one out.
Oh, sorry, there's one.
How do you guys handle like upserts and deletes in or like slowly changing dimensional data?
Yeah, yeah, absolutely. Deletes are handled, we do soft deletes. And then if you want to delete, like do a hard delete, you do that in post basically. Um, and upserts, yeah, that's kind of what I was talking about in terms of like, for example, data type detection, or if like you add a column or something, will automatically migrate the schema. And yeah, when it comes to data type detection, we're upserting to the a type that can contain whatever's in that column. And then we essentially do some metadata tracking about what has been changing with the schema, so you can kind of go back and see how the schema's drifted.
Cool. Second question was around permissions and like who are the users that are going to be like in the UI building these things, or and how do you section that off for like things they can touch and shouldn't touch, or how do you guys handle that?
Yeah, I think that's going to get more important as we get farther along. Traditionally, we have a kind of just a typical like role-based access control scheme. And the product has historically been targeted towards data analysts who may not be like IT specialists. So potentially you can have somebody who's relatively non-technical manage the whole thing. But we have enough permissioning set up so that you can assign somebody to be, for example, a viewer only of the entire project. And we even have a functionality where you can make somebody, all they can do is come into the UI and use it to upload a CSV file. Because that's kind of like this convenient functionality. If you just need to like pop in a spreadsheet or something. And that goes all the way up to you can do everything on the account. So we do that. That's basically how it works. It's just basic role-based access. I think that will shift into something that can be probably externally managed a little bit more, so that your roles come from a system. They like flow through the system. So maybe they're derived from what's set up on the data warehouse side, or they're derived from some external system that's driving the policy for those things. Like at the end of the day, it's really important for us as a product to understand that we're in the middle of a broader system. And generally speaking, nobody wants to have to control the policy for every little bit of that system. So I think going forward, we'll be working on functionality that allows us to adapt to a more general system policy. But like it's weird having closed that Series C. It feels like we've moved a lot in the last year, but we're still a startup. We're we're still kind of like transitioning from startup to we really got to make the stuff work for enterprise. So
the reason I ask is just like what I had in mind was I would love to give more downstream customers and analysts, and maybe like, I don't know, people that maybe upstream, like maybe the Salesforce team, are asked to give data into the data lake and they could have access to this. But what I wouldn't want is if someone added a Salesforce connector, I wouldn't want someone to go in and like change and say hash out these columns and
oh, interesting. Yeah, I don't know if we're that granular. I think you can either add a connector period, so that means control all aspects of that connector addition, or not. I don't know that we have it. In fact, I'm very confident that we don't have it so granular that it's like you can create this type of connector, but you actually can't control the schema or can't control the duration or anything like that. We do have an API, and so it would be possible to do that through the API, like have part of it's templated and part of it is like, you click a button and sign in and then it starts syncing. That is possible through the API, but not through the user interface the way you're talking about. And also, like, really what you're asking is like, can you control that from a role perspective as opposed to from a programmatic perspective? So the answer is basically no. But it's a great idea. Yeah.
Any other
I think
questions?
this is the point where we'd all grab a beer and eat the chips and hang out.
Yeah.
I'll throw one more question out there. I know that you guys are mainly towards destinations like Redshift, you know, a data warehouse. Like, have you considered or talked about going to S3 as a destination?
Yes, absolutely. So actually, we got pretty far down that path, and we kind of had this like, it's that whole like 80%, 20% rule. We got down to the last 20%, and we realized there was like another 100%, and that we hadn't necessarily made decisions there yet. You know, we were really storming down this path of we're gonna land everything in this Netflix iceberg format. It's like a combination of Avro and Parquet, and it's going to work like we're just going to dump the files in S3 and that's it. And as we kind of got further along, we realized, oh, this doesn't actually meet the actual use case that people are going to have, including like integrating with Glue to do data cataloging and all this other stuff. So we're still working on it pretty, what am I trying to say? It's still in process. We're still working on it, but we had a commit date, and then we basically said, we can't commit to anything yet because we realized there's more that we didn't know. But I think it's a super important use case. And like, I kind of mentioned this before, but as much as I was talking about, oh, everything's so cheap today, it's not necessarily. Depends on your business and the data you're loading. And I think it's going to be super important for Fivetran to be able to land data in the data lake, whatever that means for a particular context. But again, moving towards bigger use cases, it's part of our growth. It's part of where we're not quite yet.
Yeah, I mean, you'd mentioned Databricks in passing with the DBT part, and then
yeah, we integrated with Delta Lake. They created essentially what is they coined the term data lakehouse, which then Amazon jumped all over. But the data lakehouse, so Delta Lake is essentially a data warehouse like interface that's built on top of the Databricks stack. And so we are loading data through Delta Lake, which looks a lot to us just like a normal SQL, data warehouse interface. And that does wind up landing in a data lake that is then accessible to the Databricks stack. And so that actually was great. Yeah, so we do that. It's great. It's really helpful for us to get to say that we support data lakes, but it's also you either use Databricks or you don't. So, it's a very specific use case. But again, that's kind of like, I think it's going to be super important going forward, especially as we move into more machine learning use cases.
Thanks.
No problem. Thanks for the question.
other questions? Or is it beer time? So.
Or sleepy time. It's an hour later for you guys, so.
Yeah.
Netflix time.
Well, cool. Well, thanks everybody, and thanks Craig and Kristen. This has been great. So.
Yeah, it's a real pleasure. I really appreciate having the opportunity, folks. Thanks for your attention, and yeah, I hope it was useful. If you have positive comments or negative comments, email me. I'll take them. I'll take them either way.
Cool. All right. Well, I'm gonna stop recording, and yeah, if you guys next meetup again, it's August 19th, Apache Kylan. So it's sort of a next gen data warehouse in the Apache project. So hope you all can make it. So, all right. Until then, we'll see everyone later. Signing off. See you guys.